Alright, hello children, it is I, Mr. Cthulhu, also known as John Paul to some of you. Either way, those are both fantastic names. One of them is a pope, the other one should be a pope. So, I have been working on this. This is my passion project, and my passion project is something that I had to do for school, but it's driven by my passion, so it's fun, or I guess. And I have to make a video game. Well, I don't have to, but that's what I chose to do because I'm interested in programming. And so I created a video game. It took me about 1 to 3 months, depending on the way you look at it. Either way, it did take a significant amount of work. And I made a short video explaining the basics of how it all works. But in this video, this is probably going to be a lot longer because I'm going to be a lot more detailed with how everything works. So, first I'm going to show you my wonderful little game. I don't think it liked that. Here it is. So, here I am. I am Shrek. I am running through space, as you can tell, and there are onions that are chasing after me, and I need to avoid them for as long as possible. You can see the timer in the top left. There's music, but I have the music turned off for you guys. I can hear it though, and it's pretty epic music. And so yeah, there you go. When I die, oh no, I'm dead. Aha, I'm back. You thought I was gone, but no, it is I, the undefeatable Shrek, and I shall return from my slumber. Okay, anyways, it's a relatively simple game. Some onions come from the left, some onions come from the right, some come from the top, some come from the bottom. It's not much going on here. Well, actually, there is a lot going on here, but visually, it's a pretty simple game. And so, yeah, there you go. So now, I'm going to show you how it works. So before I explain anything else, I need to explain scenes and nodes. So a scene is basically any section of the overall project. So this whole thing is called Onion Rush, the game, and the whole game is a project file. And this file it's divided into a lot of different things, but an easier way for me to access it is through scenes. Now, I could just put everything under this one main scene, but it's a lot easier to not do that. And so what I have instead is I have these little scenes which are put under my main scene. In fact, under this onion main scene, I have each of my individual onions, which there are actually only 6, but they're teleporting. But I'll get to the onions later. So let's use the player scene as an example. So if I play the player scene, so this is just, for example, this is like the player part of the game. By putting it into the main scene, I'm making it run along with everything else that is going on in the game. And so if I just play the player scene, then there's no background, there is no onions, there's no way to die, but if there was, then there would be no respawn. It's just me, the player. And so there are also nodes, and nodes are a part of a scene. They're individual parts of a scene, so you have this root node, and this is the basis for any nodes that you put under it, and it's the defining node of a scene, if that makes any sense, okay? So this is an area 2D node, and it's pretty self-explanatory name. It's an area, and it's 2D. And this is called player, and so the scene is called player. And so this is our root node. It's an area 2D. As I said before, it's an area that's 2D. This is an animated sprite node. Now this is a child node of our player node. And a child node basically means this is a part of this main node here. It's gonna function under it or with it. So for example, this animated sprite needs this area 2D to work, and this area 2D, well, in this case it needs this animated sprite to work, but in some cases it wouldn't. But I'll get to that later. And so this animated sprite node, a sprite is usually the term for like an image of what whatever you're trying to make looks like. So in this case, it's 2 frames actually. So over here, there's this frames option, and I can change the frames to like a new sprite frames, which I have down here. This is so we can make different animations and switch between them, but for this I only have 1 animation, and this is the run animation. So as you can see, it has 2 frames, and I should be able to play it. It's not gonna let me, but you would be able if it was gonna let me play it. Then what you would see is that if you look closely, you can see. Actually, you don't have to look that closely. You can see his little arms and legs moving like he is running. And so that's the animated sprite's job. You can also set the speed in frames per second. I have it set to 5 frames per second. So each one of these is going to run 5 times. So the whole thing is going to run 2.5 times in a second. And this sets the animation, the default animation. So if I had multiple animations, let's say I have 4 different animations for going up, down, left, and right. I don't, but if I did, then I would have 4 different animations saying, say, up, down, left, and right. And this one, I could set it to any of those. But I don't have to do that, so I just set it to run. Hopefully you're with me so far, because I'm not the best at explaining this. And this sets the default frame. This is how this multiplies the speed. But there is all sorts of crazy stuff you can do to it. I won't go over it too much. I really want to get to the code, because in my opinion that stuff is interesting. But I'll get to that later. So this is the collision shape 2D node. Again, it's a child node of this area 2D node named player. And this is the shape that allows it to collide with other things. So this is what lets the player know when something touches it. In this case, an onion. So when an onion so it needs this to connect to this, so that it knows. So that, for example, when an onion touches that, this goes to the player node, which is in area 2D, and says, "Hey, buddy, the onion touches it," and the player goes, "Okay," and then he does more, and then the player node does more stuff, which you'll see soon. So hopefully I did a good job of explaining that. Now, you can attach scripts to nodes. And scripts are essentially little things of code. It's kind of like a script in a movie. The computer is going to do whatever you tell it to do in here. So, I am going to go through in the other video. I'll put a link to it in the description, hopefully. I just make the most basic explanation of this, but in this, I'm going to go into as much detail as possible. So, are you ready? Hopefully you are. So, this script is attached to the player node, meaning that whatever happens in here is going to happen to the player, not to the onions or anything else. Make sense? Cool. Hopefully. Okay, so we start with this, extends area 2D. So if I had a different kind of node that wasn't in area 2D, for example, this, let's say, onion main node, it just says extend node, because the node type is just a node, and I'll explain what that means later if I don't forget. And so basically, I'm not entirely sure what this means, why this is here, but I do know that you have to have this for everything, because if I get rid of it, then the computer doesn't like it. Okay, so you can have variables, and variables are abbreviated by VAR, and they are, in fact, variables. And they can be a lot of things. They can be integers, which means a whole number. They can be floats, which means a decimal. They can be strings, which means text. They can be booleans, which means true or false. They can be a lot of things. In this case, we're just saying var, which means it can be anything. It could be any of those. But we're saying equals 400 so that the computer knows, okay, this is going to be an integer because it's not a decimal and it's a number. And so this is var speed equals 400, and this is how fast the player moves in pixels per second. In this case, it moves 400 pixels per second. And export, if I add export to this, then I can, if I got rid of export, then I could still just change how fast it moves in here. But by adding export to it, I can go here, And see, I can change the speed. I can change it to 401. I can change it to 399. Or I can just get rid of export, and if I go back to player, it's gone. It is no longer there. So that's why export is there. I personally don't use it, but I have it there just in case. So variable screen size. So screen size is the size of the screen, and this is stored as a vector 2 generally. And a vector 2 is, I'm not even entirely sure of what it is myself, but my understanding of it is that it's kind of like a position or a size. Basically anything that's 2D. So in this case, it's two values, an x value and a y value. And the x value is set to the size of the screen on the x-axis, and the y value is set to the size of the screen on the y-axis. Hopefully that makes sense. Now I have the signal stop, and this signal can be sent to other things, and this stop signal is sent when it touches the onion, and I'll cover that later. So, you can have these things called functions. They are abbreviated func. And so this is the ready function, and this is called essentially, so anything that is put inside of here will happen when the game first starts. It also says when a node enters the same tree. That's basically fancy language for when the game starts, or for when the player start part of the game starts. And so we have screen size. So screen size is our variable up here. That's the size of the game window. And we're saying screen size equals you get viewport rect dot size. So what we're doing to screen size is we're setting screen size to be equal to the size of the game window, which is this right here. So it's going to take the x value of that and the y value of that and transfer it to screen size. Hopefully that makes sense. So now we have position equals screen size over 2. So it's going to take the position. So position is used to set the position of the player, obviously. And so the screen size, screen size can be divided by 2. So think about it this way. If it's not this big, let's say that on the x-axis it's 1000 pixels big, and on the y-axis it's 2000 pixels big, just for an example. So it's going to divide that by 2, and then it's going to get the position, which on the x-axis would be 500, and on the y-axis would be 1000. And so then it's going to take that position and set the player's position to be there. And so if we do all that, and not using the same sizes, then it takes takes our little player and puts him in there. Okay, cool. So now we have the process function, and process is called every single frame. What you could do is just call it 60 times a second, but sometimes, because there's generally 60 frames in a second, but sometimes there's lag, and sometimes people have super fast computers, so sometimes it's going to be more or less than that, and that would totally mess things up, and you don't want that. So we have delta. Delta is the amount of time since the last frame happened. Hang on 1 second. Okay, so delta, anyway, as I was saying, delta is the amount of time since the last frame happened. And so if you use this, then this will stay consistent no matter how long a frame is or how many frames there are per second. So we have variable velocity equals vector 2. So this is a new variable. This is the velocity of the player, okay? And we're setting it to a vector 2. So a vector 2, as I said before, stores an x value and a y value inside of itself. So, down here we have if input is action pressed UI right. So this is saying if we are pressing the right arrow. So it's taking the input of UI right. And if we go to project settings, input map, as you can see, if we go to UI right, this is set to the right arrow. UI up is set to the up arrow, UI down is set to the down arrow, and I don't know where UI left is, but it should be set to, yes, it's set to the left arrow. So in this case, it's set to the right arrow, which is UI right. So we have velocity dot x plus equals 1. So velocity essentially is kind of where the player is going to move, if that makes any sense. That's not exactly what it is, but we'll get there. So plus equals 1 adds 1 to it. So it's gonna set the x value of velocity to 1 so that it moves right. And this, if we're pressing left, it's going to just subtract 1, which is going to make it move left. Because if you've ever looked at a graph, left is usually negative and right is usually positive. Additionally, up is usually positive and down is usually negative. For some reason, somebody decided they're going to make it hard, and so that's not going to be the case. Instead, down is going to be positive and up is going to be negative. So here we set, so instead of dot x, we set dot y to 1 for down, because down is positive for some strange reason. And here we set velocity dot y to -1. And this is for the UI up. So are you with me so far? Because hopefully you are. If you're not, it's only going to get more complicated from here, so I suggest you click away from the video. Now, hopefully you're still here, and if you are, so we have if velocity dot length is greater than 0. Now, I'm actually not, you know what, I'm not gonna lie, I actually don't know what this does, but you can't make the player move without it. So if anybody has any idea as to what this does, please let me know in the comments. That would help. So anyways, let's just ignore that. So you have animated sprite dot play. So this little $sign here, this is short for get node. I wrote it up in a comment up here. You can add hashtag before something to make it a comment, and that means that whatever's in there, the computer isn't going to take it as code, it's just going to ignore it, so you can write anything there. So in this case, $sign means the same thing as get node. So I can also put get node animated sprite dot play. So this is going to find the animated sprite node, and it's going to play it. And so, yes, that's pretty self-explanatory, it's playing it. So this is the animated sprite, so it's going to set the animation value of animated sprite to the run animation. So if I go here I have the animation thing, and this is set to run currently. What this can do is, let's go back here, this can actually change that if it wants to. And in some cases you'd want that. I don't, because I don't need that. So there you go. That's what that does. So we have position plus equals velocity times delta. So again, delta is the amount of time since the last frame. Velocity is where the player is supposed to move, I think, and position is the position of the player. So it's going to add this to the player. So the time of it plus velocity, times velocity, and then it's going to take the player where it's supposed to be. And voila, you have been where you are supposed to be. Now, technically, you don't need these two lines of code, but they're really good to have, because just for experiment's sake, let's comment these out, meaning they are now comments, so the computer is no longer going to register these as code. It's just something that we have for convenience sake. So if you press play, hang on, actually I don't want to do that. I just want to press play scene. Hang on, temporary difficulties. Okay, so everything is still the same. We can move around. However, there's something strange going on here. We can go past the limits of the screen, and that's not good. We don't want the player to be able to cheat by chilling out off the screen where all the onions can't get you. And so this is going to clamp the position, meaning the position the chosen value cannot go higher than whatever it's going to. And so basically, this is going to clamp it on So this is clamping the x value of position, so where the player is on the x-axis, and it cannot go past 0, which is, let me play this real quick. It cannot go past 0, which is right up here, or screen size.x, which is down here. It also can't, no, sorry, 0 is here, screen size.x is here, and then we also have 0 and screen size.y. Hopefully that makes sense. So you can't go off the screen, essentially. Now we have function on player entered area, and so this happens when the player enters another area, and when this there are only the only other areas that are important are the onions, and so the onions. So when it so let's start over. When it touches an area, in this case the onions, it is going to emit the stop signal. And this signal stop. This is currently not set to do anything, and you actually can't really make it do anything in here. So, and then it's going to hide. So when you touch an onion, the player becomes invisible. So let's go to our main scene. So if we go to the node section over here, we have this stop node, and I can connect it to anything in here. I'm not going to right now because that would mess it up probably, but that's what it does. I can connect this signal, and by connecting that signal I can create a function, and anything inside that function happens when the player sends the stop signal to the chosen node or scene. In this case, these are all scenes, most of them. So I have the respawn here. Actually, let's look at the onion main real quick. So onion main is its own scene, and onion main is a node. So onion main itself isn't actually anything, but you can put other nodes and scenes under it. In this case, these are all separate scenes. So if I go to onion 1, then you can see the onion 1 scene. If I go to onion 3, then you see the onion 3 scene. There are, in some cases it's different, but I'll get to that later. In this case, this is the case. So this has a sprite, not an animated sprite, because the onions are not animated in Occlusion Shape 2D, so very similar to that of the player. And so if we go to the onion main, so we have unplayer stop. So this is gonna happen, anything in here is going to happen when the player when the player sends the stop signal to it. So it is going to send the stop O signal, and stop O is short for stop onion. And what I can do is this sends, hang on. Okay, sorry. Hang on, I think I might have messed something up. Temporary difficulties. Okay, right, I'm good. So, anyways, when this onion 1, so when onion main, when onion main receives a stop signal from the player, it is going to emit the stop O signal to these onions. And let's go to the onion 1 script. I will explain all this shortly. We have on onion main stop O, then it's going to hide, and it sends all of these things to here. And so if we play it, so here I am running around and I'm going to get hit. So I've been hit, and what happened when I was hit is a signal was sent from the player to onion main, and a signal was sent from onion main to the onions to tell them to hide, so you cannot see them. And it all happened very quickly, so you don't notice anything. But actually, there's a lot going on. And you can kind of cheat by pressing space, because when you press space, it goes, it moves you back to the center of the screen when you respawn, but I don't know. There's not really a lot that you can do with that. So, anyways, right, let's go back to this. So, I will explain how the respawn function works. It's not a function, I shouldn't say function. The respawn mechanic works. So, it's actually pretty simple. So if you go to the respawn node, it's another area, and this doesn't have a collision shake 2D because it doesn't need to collide with anything. It just needs to know when the player presses the space button. So here we have, so all we have is a sprite that says press space to respawn. And so we have, so variable screen size is, again, the same, so the game window, and another signal called start. And so the first thing that happens is it's just gonna set the screen size to the size of the screen. It's gonna set the position to halfway through the screen. And it's gonna hide, so that when you first start the game, you don't see it. Then this is going to, so this is saying if you press the UI accept button, which in this case is space and enter. It works with enter too. You're supposed to press space. It's gonna emit the start signal, and then it's going to hide. And when it receives the stop signal from the player, it is going to show. So it's hidden except for when the player receives the stop signal from the player. And so it's going to emit this start signal, and then it's going to hide. And it sends the start signal to the player and to Onion main. And so the player receives it. So if you go back to the player script, as you can see, it shows, and then it puts you back to the middle of the screen. And what Onion main does is it sends the start O signal, which goes to here, to the onions, and they receive that, and they show. So hopefully all of that makes sense, because I know that this is a lot to take in. So, let's not cover everything we've learned so far. Let's dive into how the onions work. So, we have extends area 2D again. We have the speed again, screen size. I didn't need these two. These were going to be the X values and Y values of the screen size, but I didn't need these after all. We have spawn height, and spawn height is where it spawns along the Y axis, so how high up or down it spawns. Spawn size is where it spawns, is which side it spawns on, so right or left. Spawn sized DET, or spawn sized determiner, is going to determine which side it's going to spawn on, and I'll get to that in a second. And direction is going to be 0, and this is kind of like, I'll get into this later, but it's whether it goes right or left. And end timer, I'll cover end timer in a second. So we have the ready function. So screen size, I have these, which are more screen sizes. I don't need them, but I'm keeping them just in case. Also because I really don't want to put in the effort to get rid of them. Anyway, so we have randomize, and this makes the spawn height values and spawn side. Anything that you randomize will become truly random. And essentially, if you don't have this, then they will come up with the same random values every time. So you don't pick the values, but it still comes up with the same ones every time, which is kind of lame. And so this actually makes them random. How does it do that? Great question. I have no idea. So now we have spawn size determiner equals randy to something 1. I'm not exactly sure how this whole thing works, but basically this is going to select an integer between 2 and 1. And an integer is a whole number, and there are only 2 whole numbers between 2 and 1, and those are, you guessed it, 2 and 1. So based on that, the spawn side determiner, so if it's 1, it's going to set the spawn side to -100, which sets it to the left. If it's 2, then it's going to set it to 1302, which is going to put it on the right. And then it sets the direction. If it's this, it spawns on the left, and the direction is set to 1, which will make it move right. And there's this, which will make it move left. Does that make sense? Hopefully it does. I don't need this. You know what? Whatever. When I was first trying to figure out how to get this whole mechanic to work, I originally had a opposite spawn side variable, and I got rid of it. So I have these things here. Okay, so now so this changes the sprite's direction. So the sprite is normally facing right, so this keeps everything the same. when it's facing to the, when it's going the right, when it's, okay, when it's, you know what, never mind, this just flips the sprite's direction. And it does that by changing the x value to -1, so it makes it -1 times as big, so it's just as big, but it looks flipped. Okay, that was not very well said, but I just got it out of my mouth. Okay, spawn height equals that. This sets spawn height to remember between 12,002 and 1, and that makes everybody happy. Actually, no, 1,002 and 1 are the size of the values, and so then it sets the position to spawn side on the x value, so left or right, and spawn height on the y value. And so spawn height, so yeah, that's pretty much what it does. Okay, now we have the process function again, which is again called every single frame. So we have this velocity variable again, and we have this end timer variable, and so end timer, so this is going to add 1 to end timer every single frame, so generally this is going to add 60 to end timer every second. So this is if end timer is equal to 240. And so this is essentially, that's the amount of time it takes to get from one side to the other. So this is setting, okay, so this line here is setting velocity.x to the direction, so 1 to go right and -1 to go left. We set that earlier. And okay, so again, here we have if end timer is equal to 240. And then we have, so it's going to do everything we did up there. And 240 is 4 seconds, which is about how long it takes for the onion to get from one side to the other. And then it's going to do all this again, and it's going to set end timer to 0, so that once it gets to 4 seconds again, it is then going to once more do all this. So the result that you get, so let's go to the onion main scene and play that. So the result that you get are these onions that look like they're actually coming from where they're supposed to be, because if they come from somewhere, once they get off the screen, here, I'll play this. So here you can see once they get off the screen enough, it looks like they're disappearing, but they're actually just teleporting to somewhere else. So that's how the onions work generally. And so for onion 2 and above, all of this stuff is in if start timer is greater than or equal to 60. So this is basically, it's going to wait 60 seconds and then it's going to start going. Sorry, not 60 seconds. It's going to wait 60 frames, which is a second. Okay. So, and I've been talking for so long that my mouth is starting to no longer work. So this is going to start making less and less sense, so I better hurry up and finish this. And I'm almost done. So I'll very quickly explain how the, you know what, I'll just say this, it just sets spawn side as the x-axis thing and spawn height as this. It changes the values slightly. Other than that, there's not a whole lot going on here. Okay, so yeah, that's how the vertical onions work, and there are actually, as I mentioned before, only 6 onions. It's just that they teleport in and out so that it looks like there's more, and that they're just coming from all over the place. Okay, whew. Let's cover the background. So the background is actually, the background is actually one image. So I made a background, and then I copied it, and I put one above the other. And so then it was one background duplicated twice. And so that means, so the speed is 601 pixels per second, which is half of the screen per second. So it's going to take 2 seconds to get through the screen. So let's go to the background scene. So if we go here, it's taking 1, 2, 1, 2, 1, 2. And if you look closely, look at this curve of stars. You'll see this recurring every single time. It's actually just the same background over and over. And it's a little glitchy. That's because, again, the frames per second is a little weird, and I don't exactly know how to fix that. But pretty much, and it adds 1 to this timer variable. You have velocity dot y is equal to -1, which makes it move up. And we have, if the timer is 118, which is, I found it better than setting it to 120, which is 2 seconds, just because of a little bit of lagging. Then it's going to set it back to where it was before. It's going to reset the timer, and it's going to do this until the game ends. And then it has the position plus equals velocity times delta. Whew. Okay, so I'm pretty sure I covered everything. I might not have. Is there anything I didn't cover? The timer. I haven't covered the timer. I'll cover the timer. Okay, let's cover the timer. So, extend rich text label. So rich text label is basically text. So we have 4. Let's go to the timer scene over here, because it's its own scene. And so instead of an area 2D, we have a text label, because this doesn't need to collide with anything. So we have variable milliseconds, which is milliseconds, and this is the milliseconds thing that actually, this is actually what's counting it. So let's go to the timer script over here. So we have 4 variables. Yeah, milliseconds equals 0, seconds equals 0, minutes equals 0, and counting equals true. So we have if counting equals true, it's going to count, basically. And if milliseconds is greater than 9, then it is going to set then it's going to add 1 to second, and it's going to add 1 to seconds, and it's going to set milliseconds back to 0. So basically it's going to go 1, 2, 3, 4, 5, 6, 7, 8, 9, and then it's going to set seconds to 1, and then 1, 2, 3, 4, 5, 6, 7, 8, 9, send seconds to 2, 1, 2, 3, 4, 5, 6, 7, 8, 9, 3. Okay, so you get the idea. So then it's going to do the same with seconds. So if it's just 60 seconds, it's going to reset that. It's going to set the minutes to 1. That's going to add 1 to the minutes. And so this here says, so this is setting the text to str, which is short for string. So this is going to convert whatever is in here to string. So this is minutes plus a colon plus seconds plus a period plus milliseconds. So if we play this scene, as you can see here, it's displaying that. So we have the minutes, colon, seconds, dot, milliseconds. So now, if we go back to our timer script, so as soon as this milliseconds thing gets to timeout, which is basically when so it takes 0.1 seconds for it to time out, so it's going to add 1 to milliseconds every time it does that, and on player second, and so yeah, that's basically what's actually counting our thing. And so when the player stops, it's going to set all of these values to 0. So when the player gets hit, which is when the player sends the stop function, all of these things are going to get set to 0, and counting is going to get set to false. So because all this happens if counting is true, but it can't happen if counting is set to false. And so when respawn start happens, it's going to set counting to true, and it's going to start counting again. Whew. Okay, I need to make sure that I went over everything. I went over respawn, I went over the onions. Okay, so let's very, very, very quickly go over everything. So, onion 1 is it starts by randomizing the spawn site and the spawn height. And this is how all the onions work, and does that every so many seconds, however long it takes it to get across the screen. The player works by going in the direction you want, depending on what button you are pushing. The background works by teleporting down every 118 frames. The respawn thing works by showing up when you die and going away when you press space. There are scenes and nodes. Scenes is a part of the game. Nodes are part of fiends. And and this timer works by counting up 1 every millisecond and resetting as it needs to. Okay. Well, I'm pretty sure this video is about like an hour long at this point, so if you're still watching this video, I say 1, I am impressed, and 2, why? Like, what made you, you know what, whatever. Well, hopefully you enjoyed this very, very, very long video that I recorded in 1 take. And yeah, there you go. That was an explanation of how my game works. And there you go. Enjoy.